Alrighty, on to the third video. This is on cations and anions, and this is probably, I think, the most confusing part of what you need to learn for the exam. Simply because, especially for the cations, it's really confusing as to what table, and there's not always the right information on all the tables. And this table here, I actually find this probably the most valuable one to use. So what you're looking at here is this is on page 426. So basically two sides to the table. These ones here will not give a precipitate. These ones here will give a precipitate. And remember, we are looking for a precipitate to identify the cations and anions. Now on this side, what you have to look at is the exceptions. I don't know why that's missing the C. Not very good proof editing in this book. So you're looking at the exceptions. And as you can see there, chlorides, bromides, iodines only give a precipitate with silver and lead. Okay? So these are very good tests to do for silver and lead. Sulfates. Sulfates are great tests to do for barium, and they're in that flowchart, barium and calcium. But be very careful because they also give precipitates with silver and lead and strontium as well. So if we were testing to see what is in a solution, we wouldn't go straight into sulfate testing because it could be silver and lead as well as barium and calcium. Okay, so that's why we do the chloride test first, because only silver and lead precipitate. Okay, because if we went in straight in and did the sulfate test, we could get these false positives. We could say, oh, it's barium, it's calcium, but it could also be these two here. Similarly, on this side, the exceptions are the ones where it does not form a precipitate. So if we did do that sulfate test, barium and calcium, silver and lead, then I would do a hydroxide test because I know barium and calcium don't form a precipitate. Okay, so if I want to sort of eliminate some of these, I need to start looking at these different tests here. That's why I quite like this table. It provides a little bit more information when you're trying to really identify ions and you've got 3 or 4 that it could be. Now this table is probably the one you'll use the most. There's a lot of information on this table. That's on page 428, and it pretty much has all the tests that you need. Okay, so the chloride test, there's only 2, lead and silver. Now if we also want to test for lead, let's say we got a precipitate for chloride, we don't know whether it's silver or lead, then we can do an iodine test to confirm that. I wouldn't put much trust in the colors of the precipitate, because in chemistry it's very difficult to, especially if there's a mixture of cations, to get these really clear precipitates. You will with silver and lead, but you know, down here where we're talking green or white precipitate, or a brown precipitate, or a blue precipitate, it starts to get a little bit messy when we've got lots of these ions together. Now if let's say for instance we're trying to identify chemicals that may contain lead or barium or calcium, etc., we can work our way through these different tests. I'd probably use the flowchart, which is on the next slide I'm going to show you first, but this table here will help you sort of determine between cations that give the same sort of positive results. Okay, now occasionally you'll see flame tests. Flame tests are interesting. If you've got a pure cation, yes, they're really great. But if you don't, if there's a mixture of cations, you might as well forget about flame tests. If you want to appear really clever on your exam, you can talk about UV vis, okay, or atomic absorption spectroscopy. Absorption spectroscopy. Now these are two tests where you need a special machine. Okay, the UV vis machine isn't that expensive; it's a couple of $1,000. But your atomic absorption spectroscopy machines can be up like $10,000. They're not something high schools have, but you will use them at uni. If you do any science at uni, you probably will or any chemistry at uni, you'll end up using these here. I think I even started using them in first year chemistry when I did my science degree. Very common machines in research, and they will give you very, very exact results. So if I had a mixture of cations, I'd throw them in one of these machines and it would tell me exactly what's in that mixture. Okay, so this here, I would use the flowchart first, then I would use this to try and work out what the individual ones are, sort of just to confirm and back up what you think it would be. Now remember, for all these tests, you're trying to eliminate things, okay? What it is and what it isn't. So what it isn't, it can almost also be as important as what it is. Okay, so this is the second flowchart. So this is on page 432. And I like this one because this is to do with mixtures. If you think about it, we're testing metals, we're testing cations, and a lot of these tests are done on water, and in water you're going to have a mixture. Very, very rare that you would have just one cation in your sample. So this flowchart steps you through step by step what your reagent is, what are the results you expect at each stage. And look here, we do that chloride first to eliminate the silver or the lead, because I know if I add sulfate, my lead will give a positive reaction to that, will give a precipitate. So I want to get rid of or eliminate the lead first. Okay, so this is why we do this in this exact order. We can't skip steps here, we have to do it in this order. So we start with the chloride ion. If it gives a precipitate, could be silver, could be lead. Okay. If it's, could be both, so then we use some ammonia. Does the precipitate dissolve? Yes, then it's silver. If it doesn't, it's lead. Okay. We filtrate what's left over, so we get rid of that precipitate. We use only the filtrate, so the clear solution. We add fluorine. Okay. So fluorine is a great test for calcium. We add sulfate. So sulfate will give a positive for barium and also for calcium. So that's why we do the fluorine up here, to see if it is calcium. Okay. So we can eliminate them. Then we move down to the hydroxides. And lots of things give precipitates with hydroxides. Lead will, I think barium does as well. So that's why we eliminate them up here. So no precipitate means that it definitely is not copper, zinc, or iron. Okay, so these, a little bit confusing here, because these mean that if there is a precipitate, then it is copper, zinc, or iron. Okay, so let's say we've got a precipitate. We add even more of the sodium hydroxide. So if that dissolves the precipitate, then it's most likely zinc. If there's still some precipitate there, it's probably going to be iron or calcium. So we add some ammonia and see what color the precipitate is. Okay. Now just be careful, because these flowcharts only test for silver, for lead, for calcium, for barium, what's the other one, for zinc, for iron, 2 or 3, and for copper. Okay, they don't test for any of your heavy metals, so we need to be very careful that the flowchart only tests for these ones here. Now, you could very well be asked to, you know, for a heavy metal, and this is page 434. So heavy metals, things like chromium, arsenic, mercury, very, very toxic to humans and wildlife. You don't want these in the water at all. Okay, we'll put lead there too because it's a heavy metal too. So we want to do a test for these, and the test we do is the sodium sulfide. Okay, so if we get a precipitate, we add some sodium sulfide. If we get a precipitate, we acidify it first, so we add some acid, and if we get a precipitate, then it could be lead, could be silver, could be mercury, could be copper, could be cadmium, could be arsenic. Now we should already know if it's lead or silver. Okay. If there's no precipitate, what we need to do then is make it alkaline. So we're going to add some base. And if we get a precipitate there, using the sodium sulfide still, if we get a precipitate then it could be chromium, could be zinc, could be iron 2 or iron 3 plus, it could be nickel, could be manganese, could be cobalt, could be aluminium. Alright. Now, we can't really tell which one it is, so we'd have to do further tests. So you'd have to do your atomic absorption spectroscopy or your UV vis to work out exactly what heavy metal it is. Okay, but these give, so you will get a precipitate. If you get a precipitate, it's a heavy metal. If you get a precipitate in a base, it's a heavy metal. Okay, now the other thing we need to talk about is iron. Iron 2, iron 3. Okay, now iron 2 will oxidize into iron 3. So we need to distinguish between them. And the test for the two, so for iron 2, we use the permanganate. And permanganate is a lovely purple color. Okay, so we use purple permanganate, and it will decolorize. So it will actually go clear. So if the solution goes clear, we know iron 2 is there. Okay, now for iron 3, we want to add some thiocyanate. Okay, and that's your SCN negative. Alright, we add some of that, and we should have a deep blood red color. Okay, now this is colorless, and we form this deep blood red color. So if we do, then iron 3 is there. So remember these tests for iron 2 and iron 3, and remember the sodium sulfide test for heavy metals. Alright, not cations, anions. Okay, this flowchart, what page is this flowchart on? This is page 438. Okay, so again, have to follow this in the order. So this is always going to be number 1. We want to add acid, maybe even warm it up a little bit to see if there's a carbonate present. So if we get bubbles bubbles of carbon dioxide. So an acid plus a carbonate give carbon dioxide gas. So if we get bubbles, we know there's a carbonate there. Now we have to do this first because carbonates will react with barium. Okay, so if we do this second, if we just add barium straight away, we could get a color change, a precipitate, and we think it is sulfate, but it's actually carbonate as well. So we need to do the acid test first. All right, then we do the barium. Okay, we test for barium, we add barium, and if we get a precipitate, most likely it's sulfate. We filter that out. We want to make it more basic, more alkaline, so we add some ammonia. Okay, if the barium, and then we add some more barium. So if the precipitate forms, we have phosphate there. Okay, we filter it out, we add some more acid, and we add the silver. And this will test for chloride. So silver is a great test for chloride. We could use lead or anything like that, but silver, I like using silver. It works really, really well. And if you remember back to year 11, when we were doing the Brisbane River, we used a lot of the silver nitrate, and we reacted that to see how much chlorine was present. Okay, so it's the silver that reacts with the chloride. All right, you may need to refer back to the tables on the previous page if this flowchart here doesn't make a real lot of sense for what you're trying to work out. So let's actually look at how we might go around solving a couple of these. All right, so this is a cation question, straight from the textbook. How would you decide whether the heavy metal in a water sample was lead, okay, silver, or barium? So explain carefully. So we've got two parts of this question. How would you? Okay, so number one, what are the tests? Number two, explain carefully how your results prove the presence of one ion and the absence of the other two. So we want to say how the results confirm the presence, or for that matter, the absence. Okay. All right. So let's have a look here. What would I do? Okay. I'd look at these two first because I know these two react with chloride. Okay, so my first test, and I might write this down as dot points, would be to add HCl. Okay, and if I get a precipitate, that means that it could be lead or silver. Okay. All right. Now, if I don't get a precipitate, I know it's not lead or silver. So no precipitate, no lead or silver. Okay. Now I want to do something here to confirm which one it is. And if we look at our table or the flowchart on page 432, it says to add ammonia. Okay. So I add some ammonia. Now, the precipitate. If the precipitate dissolves, then it's silver. Okay, so I've got my precipitate. I add some ammonia. If it dissolves, it's silver. If it still is a precipitate, then it's lead. Okay, so I've now determined which of these two it is. Okay, now if there's no precipitate, even if there is a precipitate, I would filter it and I would do this next test anyway. Okay, so the next test to test for barium is to add some sulfate. Alright, and if I get a precipitate, then it's most likely barium. Okay. So that's what I would do. So this here would be my second test, this here would be my third test. And if I wanted to, I could write something, chloride tests positively for lead and silver. Oh, can't spell silver, but that's right. If precipitate, then ammonia added to determine if lead, and I'll put in brackets here, precipitate stays, or silver precipitate dissolves. Then add sulfate to new sample if precipitate, then barium present. Okay, so what I've done there is I've shown the tests, and I've written a little bit about my results confirming the presence or absence of the cations. Similarly, we have a question on anions. So what we've got here is a table that so we want to work out whether A is a carbonate, B is a carbonate, whether A, B, C, or D are carbonates, chlorides, phosphates, or sulfates. Now carbonates. Now this is why we do the carbonate test first with the acid, because carbonates give a bubble of gas with nitric acid. Notice how none of the others do. Okay, so straight away I know that this is carbonate. Now if I did the barium test first, look at that, two of them give a white precipitate, the carbonate plus something else. So I'd be in trouble if I did the barium solution first. So that's why we do the carbonate first. Okay, so we've done B. B equals carbonate. Alright, let me go to my table, and barium. Barium can be positive for sulfates, or in low pH phosphates. Okay. All right. And my flowchart also says that silver gives a test for chlorides. So I could have chloride there, I could have chloride there. Okay. I could have sulfate here as well. Alright. And I could have phosphate here and phosphate there. Okay. Now, reading this, they're containing pure substances each. So I can't have multiple substances. Okay. So, this one and this one I can actually determine, can't I? So I'm going to say that this one here, A, is chloride, because only that test, there's only that test there that's positive here. This has two that are positive. So it could be chloride here, but because there's this other positive test, that sort of makes this one have to be chloride. Likewise over here, there's only one positive test, so this one has to be my phosphate. Okay, so I've done my carbonate, I've done my chloride, I've done my phosphate. That means, ergo, this one must be my sulfate. Okay, and if I wanted to, the question doesn't ask me, but I could write out a little thing about why. Okay, so I could write CO3 gives bubbles with acid. Chloride gives precipitate, and a white precipitate with silver. What have we got? SO4 gives precipitate with barium in acid. And phosphates give precipitate with barium in a base. Okay. Now we've only got these 4 tests. Okay. So if you do look on that table on page 437, you'll see some different tests that we could also do. For phosphate, for instance, we can acidify it and add ammonium molybdate. That's a very, very common test that they use in water a lot. The chloride, we could dissolve the precipitate in ammonia. Sulfate, we could add lead nitrate, and that gives a white precipitate, and so on and so on. Okay, so you've got your textbooks there. You've got all the different tables. You may have to use more than one table. Okay, so don't think all the answers, all the solutions are just in one table.